Right. We'll go ahead and get started. Good afternoon, and thank you for joining this session of the TCS Coastal Connections Web Conference Series. I'm Steve McLeod, your host and member of the Coastal Society in Buffalo, New York. Our trending topic today focuses on coping with PFAS in Cape Fear and beyond. Our guest presenters will be summarizing the prevalence of PFAS in the environment with focus on coastal region of North Carolina. The panelists will also provide an overview of the potential impacts on the environment and human health, as well as highlight some approaches to addressing the issue, such as the establishment of drinking water treatment and monitoring programs. Please note that this session is being recorded, and the recording will be posted on the TCS YouTube channel in the coming days. For our non-member guests, the Coastal Society is a nonprofit organization founded in 1975. We are celebrating our 50th year, focusing on a mission of fostering dialogue and advancing education to promote the wise use of our coastal resources. You can learn more about TCS and become a member at www.thecoastalsociety.org. The Coastal Connection series is meant to better connect TCS members and guests from the coastal community throughout the year. Our intent is not only to learn from our knowledgeable guest panelists, but also to see and hear from you, our other participants, during the Q&A session later in the program after the presenters have completed their presentations. We encourage you to turn on your camera and share your questions and comments at that time. However, you can also enter your questions and comments in the chat window at any time during the session. We'll also send you a link to a brief survey after the session. Please complete that to help us improve our program. Now I am happy to introduce our moderator for today's session, Genevieve Guerry. Gigi is a PhD candidate at East Carolina University in the Integrated Coastal Sciences program. Her dissertation work has been a collaboration with different stakeholders from Wilmington, North Carolina, to understand human response to chemical contamination. She's interviewed and surveyed residents about their experience, knowledge, and understanding of the PFAS contamination issue. Recently, Gigi has joined Wetlands Watch in Norfolk, Virginia on the Flood Risk Project staff. Gigi, over to you.
Thanks, Steve. Hi, everyone. Welcome. Nice to see some returning faces and welcome new ones. I'm going to go ahead and kick us off with our first panelist, which is Dana Sargent from Cape Fear River Watch. Dana earned a Bachelor's of Art in Journalism from San Diego State University and a Master of Science in Environmental Sciences and Policy from the Johns Hopkins University. She is proud to serve as the Executive Director of Cape Fear River Watch, a small but mighty environmental nonprofit based on the southeastern coastal city of Wilmington, North Carolina. She has two brilliant and talented daughters whom she loves to share music with, art, and travel. I will turn it over to you, Dana.
Thanks, Gigi. Great to see you again. Just making sure you guys saw that message in the chat. There's a person waiting to get invited in via audio because I know you were talking. Can everybody see my screen? Can someone just give me a nod? Okay, great.
Yes.
So thanks so much for the introduction. Thanks so much for having me. I've only got 15 minutes, so I'm going to go through these slides pretty quickly, but feel free to ask me some questions whenever. Much more information at capefearriverwatch.org/GenX. So this was the headline in the Wilmington Star News, June 7th, 2017. I was asked to give sort of a background on PFAS. I know there are a lot of people on this meeting who already know what it is, but there are still many, many folks in our region who just don't. This was our surprise in June of 2017. We had no idea. And since then, we've just been working to educate ourselves, educate the public, and engage the public on the issue. The chemical contamination of the Cape Fear centers around the Chemours company, priorly known as DuPont. You can see this on the map here, the orange box upriver of Smithfield Foods. And you can see on the box on the right, the Cape Fear River and its association with the Chemours company facility, which is called Fayetteville Works. Inside that facility, Chemours holds the permit for Chemours, as well as DuPont, a different arm of DuPont, as they've turned over their chemical organization to Chemours, and a company called Carrare. And you can sort of see in that right picture a discharge, basically a canal running straight into the Cape Fear River. We have learned since June of 2017 that PFAS had been being dumped directly into the Cape Fear River through processed wastewater, stormwater, and groundwater contamination, as well as air emissions all around the site since 1976. So what are PFAS? Per and polyfluoroalkyl substances, man-made chemicals. They were originally discovered in 1934, used in the atomic bomb. And then in 1945, DuPont trademarked one type of PFAS as Teflon. There are currently about 15,000 different PFAS in existence. And you can see on this slide many uses for PFAS. I generally say if it's slippery or water resistant or stain resistant, it's probably got PFAS in it. It's in your fast food packaging. It's obviously in your Teflon pans. There's an EPA chemist I work with who always wants me to say, anytime I speak, please don't microwave your popcorn in a microwave popcorn bag that is filled with PFAS and you're just heating it up and eating it. Firefighting foams, paint, makeup, dental floss, anything, rain jackets, again, anything that is actually, kind of resistant to water and heat is going to have PFAS in it. And they don't degrade in the environment, and they don't degrade in our bodies. I'm not going to go over the right image on this slide. It's a little complicated, but it's just kind of showing the original 4 types of PFAS that have now become used in so many things. They're in our phones, they're in medical devices, they're in a whole bunch of military uses, electronics, building materials. But there's a narrative that's been being spread around over the last couple of years about essential uses for PFAS. And this is why I kept this slide here in this short presentation, because I really want to highlight that I think we should move from talking about essential uses of PFAS and turn it into a conversation about whether or not PFAS is essential in that product. We might say our phones are essential, but is it essential that PFAS is in it? We need to start working away from filtration and toward alternatives. Filtration is just an incentive for more manufacture. This is a really good slide that was given to me by Dr. Jamie DeWitt, who's one of the primary researchers on health outcomes for PFAS. And this kind of shows high certainty health outcomes related to PFAS in the straight lines and lower certainty in the dotted lines. There's obviously a heckload more potential outcomes that would fall into the lower certainty category, because science has been continually working, but also behind since these chemicals were introduced, back in the 50s, and scientists didn't really know that they were dangerous until more recently. So we continue to have more information. It's just really hard to prove what they call causation. Those straight line items, most of those came from a study that's been known to be called the C8 study from Parkersburg, West Virginia. You can find out more about that if you watch the documentary, The Devil We Know, or the Hollywood version of it called Dark Waters, in which DuPont was found to contaminate the Ohio River Valley with PFAS, and the lawyer Rob Ballot, who we've worked with over the years, we invited here to Wilmington in 2018, basically got all of the folks in the class action to forego their payment and provide funding for a health study. So that brought in about 67,000 people into that health study. And that's what led to these very direct causation outcomes. So thyroid disease, increased cholesterol levels, liver damage, kidney cancer, testicular cancer, lower birth weight, reduced responses to vaccines, which was a really big deal during COVID, delayed mammary gland development. And you can see all the others in the dotted lines. There's also a junk load more. Brain cancer has been linked, breast cancer, ulcerative colitis, hypertension, low sperm count, increased miscarriage, and the list keeps building, unfortunately. This is just really quickly to just kind of highlight, I'm an advocate, and it matters to me that, back in the 1950s, chemical manufacturer 3M, who was the primary producer of what we call one of the legacy chemicals, PFAS, deemed that they knew in the 1950s that their primary chemicals binds to and builds up in time in human blood. In 1963, they declared it toxic. In the 60s and 70s, both DuPont and 3M found multiple health issues called inhalation highly toxic, found liver damage, spleen and bone marrow lesions. In the 1980s, DuPont reassigned female workers. Female workers were having babies with birth defects that worked at DuPont. You'll see this highlighted in the film, The Devil We Know, which you can get online. 3M workers had elevated cancer. In 1984 is when DuPont found PFAS in their Parkersburg water. We think they found it much sooner, but they did not notify the water utility. In the 1990s, 3M scientists declared PFAS the most insidious pollutant since PCB. And here we are in 2025 with this stuff still being manufactured, still being released, still being used in thousands of consumer products. I'm going to skip this one and this one. So Cape Fear River Watch sued Chemours, and we also sued the Department of Environmental Quality back in 2018. And what came of that was that the DEQ also sued Chemours, and then a consent order was agreed to by all three parties, Chemours, Cape Fear River Watch, and the DEQ, which required a heck of a lot of things from Chemours. We work daily along with our partners at Southern Environmental Law Center, who represented us in those lawsuits and represents us in a lot of lawsuits. If you're not familiar with SELC, please get familiar with them. They are essential in the environmental work of this region, and they are rock stars. We've worked with them for years on this issue and trying to make sure we hold Chemours accountable for the requirements under the order. One of them is to stop the air emissions. You can see this picture of the thermal oxidizer. I just want to note they had that thermal oxidizer in Parkersburg, Virginia, before they moved their facility to Fayetteville Works. They knew that they were emitting air emissions filled with PFAS. They came to our town and started doing it and only installed the thermal oxidizer after ordered by the court. We are also finding that the data that they've been releasing about the efficacy of the oxidizer is incorrect. We're not certain. We're very concerned that they're not capturing 99%, which is what the consent order requires. And more information will come out from that in the coming weeks. The old discharge that you saw in that photo, there is now a carbon system in place. There's a capture and filter system in place. I want to make a note here that these carbon capture systems are, one type of filtration that does filter PFAS. So they're catching the PFAS from that discharge, they're running it through the filter, and then they're dumping it back into the river. These filtration systems are imperfect. And I know we have Vaughn hopefully made it onto the call. He's going to talk about the carbon system at Sweeney. But, in brief, they're going to have to take, what they are doing is taking that carbon after it becomes contaminated and shipping it to New York, where it gets burned. And then there's a water waste to that. And that water waste then gets shipped down into Texas for deep well injection. So I just want to point out, filtration of PFAS is not the answer. You're never destroying it. You're just moving it around. The discharge of the wastewater that contains the primary PFAS from Chemours has been shipped truck by truck, month by month, since 2017 to Texas, to an environmental justice community for deep well injection, and that continues. Another aspect of the order was that we required them to do what we call non-targeted analysis. I know many of you on this call know what that is, but it basically helps to identify all the different types of PFAS in the water. We won't know how much, but we know how many. What that report found was shocking: 257 unknown PFAS coming out of Chemours alone. What we're sampling for is somewhere between 50 and 75 usually types of PFAS. So we have 257 in our drinking water supply, the Cape Fear River, which supplies the drinking water for 500,000 people, and the groundwater all around the Cape Fear Basin with at least 350 unique types of PFAS. And we don't know the levels of more than 250 of them. There's other things going on relative to the consent order. One of them is well sampling and water replacement. So for private well owners, the goal of the consent order is to reduce the discharge into the Cape Fear River, the drinking water supply for those of us on municipal, but you cannot clean out the groundwater. So the idea was to require ChemWars to conduct sampling of private well users and require them to provide filtration if they reach certain levels. These are the exceedance levels from the most latest quarterly report. It shows a total of about 10,000 in the Fayetteville region and the Lower Cape Fear region. The Lower Cape Fear sampling just started in 2022. And what we're finding, I have all these asterisks at the bottom of this slide just to make note that I just told you how many types of PFAS ChemWars is emitting and discharging. This process only samples for 13 of them. And that is because they were chosen as the most prevalent near the Fayetteville region when the order was written. Since we've learned so much since then, I am very loud about the fact that we need to require sampling of more of them, and we would need to require more protections. So this number of people have exceeded the consent order protections, which means they have to have at least 10 parts per trillion of one of those 13. And so this number is much, much lower than what is actually happening to those folks living in private wells, living with private wells. Many, many more, hundreds, if not thousands, have contaminated wells. They just haven't reached the levels of exceedances of the order, and that's not good enough. ChemWars is required to provide different types of filtration depending on what type of PFAS they have. We only have one Gen X that had a health advisory level. And so that one has a little bit of more protection for our whole house system. Many others are just getting under sink systems. And I don't know if we'll learn about food later in this presentation or not. I took it out of my slides because we were going to have a speaker talk about that. I'm happy to talk to anybody who wants to talk to me about it after, but you know, folks on wells, you know, can't use an under sink system to grow their gardens or fill their pools or use in their showers or their refrigerators or their dishwashers for that matter. But they are required to install them and pay for them for 20 years under the order. But obviously it's lacking. Here's an example of one person who fell through the cracks of the consent order requirements. He is named Ty, and he's an organic farmer, and he had PFOA, the original Teflon chemical, and many others in his wells, but he didn't have any of the 13 at the levels that would get him protections. PFOA is a DuPont chemical made at Fayetteville Works beginning somewhere around 1980, but DuPont's not liable under the consent order, only ChemWars. So he's not getting protection. So he stopped selling his produce because he's a man with ethics, and he's only been able to start again 3 years later after purchasing his own filtration system. Quickly, I'll talk about the first and only federal PFAS regulation in existence, issued 26 years after the EPA had very, very much proof of the dangers through that Rob lawsuit from Parkersburg, Virginia. And it doesn't hold polluters accountable. It puts the burden on utilities and ratepayers and taxpayers. It basically requires utilities to sample their water for these chemicals here. If they reach the levels listed, they have to provide filtration. Again, filtration incentivizes more PFAS production. Obviously, we need to filter the water, but we also need to be working on alternatives. In our middle/lower Cape Fear, the DHHS did a fish consumption advisory issued in July 2023. This is the most stringent fish consumption advisory in the state. You'll see that it suggests no more than 1 meal per year of many, many fish for folks, 0 for pregnant women, nursing mothers, and children. And this includes small fish. Those of you on here who are biologists who know, what that means. The shad is a tiny fish, and generally speaking, fish consumption advisories are more focused on the larger fish. This shows just how much PFAS is in the water. You can see the region that has been covered in red on that map. There's a lower Cape Fear fish consumption advisory in the works and out due soon. There's another company on the Northeast called Lear. Kemp, my colleague, the Cape Fear River Keeper, was out doing a flight to monitor feeding operations and saw some foam. And since then, we've done some work and did some fish sampling. This is a picture of Lauren, one of our interns. We sent our fish to the same lab that DEQ used and DHHS for that fish consumption advisory on the main stem. And what we found in that Northeast Cape Fear River fish was PFAS. They only sampled one, PFOS, same as the other study. They found 8 and 20 times more PFAS in the fish tissue sampled at the Northeast than in the main stem, which prompted that super high fish consumption advisory. There's a permit coming out from Lear, from DEQ for Lear to continue to produce PFAS. There are many, many families in that region who use that water supply for recreation. We have a really amazing activist up there who's lived there for generations, or her family has lived there for generations. Her children jump in that water and swim in that water and fish in that water. And there are many people up there who've been doing this for decades. So ChemWars is actually, I mean, it's dumbfounding, but they have issued an air permit application to expand PFAS production at their site. They're claiming they're the only company that can support green energy by creating more PFAS. And so, what we say to them is, if you are really, working in chemistry to make the world better, like they claim, you should try to find ways to support green energy that also doesn't kill people. So we are working really hard to stop this air permit. Skip this one. So most recently, our legislature last fall shifted the makeup of a commission called the Environmental Management Commission, which is tasked with pushing forward rules that would, for instance, protect us from PFAS. And the Environmental Management Commission makeup was primarily, or was in the past, a majority government appointed entity. The legislature shifted it to a legislative appointed entity. And with that, they removed 2 of then Governor Cooper's folks and added 2 that were part of the Department of Ag and suggested by our legislature. And with that, we have a polluter-friendly Environmental Management Commission. And at the latest meeting that I was at last month up in Raleigh, we were all pretty dumbfounded to hear them bragging about the fact that the industry drafted 80% of a rule that they're calling the PFAS minimization plan, which would do nothing to minimize PFAS in our water. So this is the state of our state in terms of legislation. There has been no laws passed in 8 years that would limit PFAS in our drinking water. And our DEQ has now been hamstrung by this entity, which is basically trying to take over. We have sued. We sued just most recently to stop Asheborough's pollution of 1,4-dioxane because the EMC, that Environmental Management Commission, allowed them to continue it. And then I'm going to close with just sharing some slides here of, this is my brother. He's the one on the truck in the middle. He's the one on the left in the top right photo. That's my daughter wearing his firefighting hat. And that's him and me up on the top left at the beach down here. This summer before he died, he was a Chicago firefighter. He was diagnosed in the fall of 2017, right after we found out about our contamination. And then he died 2 years later in December of 2019 of brain cancer. I have another brother who's also a firefighter in Chicago, and he's alive. And so this aspect of PFAS, just briefly, firefighters are wearing PFAS. It's in that gear. They're inhaling it when they're putting out fires where your home contains a countless number of items with PFAS in it. And they're using firefighting foams that are made with PFAS. And this is just one person who is an absolutely amazing person who may have been affected by PFAS. And there are thousands of others. And so this is one reason why I continue to do this work. And I just like to highlight that, there are so many people that I've met since starting this work that have been very much affected by this. And so I encourage you to get involved and get active and support efforts to reduce PFAS. And I'm giving you 3 pieces of legislation that I would kindly ask you to call your legislators very soon. And I would suggest actually emailing them to have it in writing and ask them to support these 3 pieces of legislation. The top two are going into committee on Monday, the bottom not yet. So the first one is Responsible Firefighting Foam Management Act. This is the third time it's been introduced. It passed the House. All the other times it died in the Senate. Representative down here, Ted Davis, has once again introduced it, and we are really grateful for his continuing support on this. This is really low-hanging fruit. It requires that they're not allowed to use PFAS-contained firefighting foam in training alone. This should never have been blocked, and it's continuing to be blocked. My brother, who is a firefighter in Chicago, says they use Dawn dish soap for training in Chicago. So please support that bill. The PFAS Pollution and Liability Act, also introduced multiple times, stalled by the Chamber of Commerce. The Chamber of Commerce brags about that in their annual reviews, that they stymied this passage. This would require Chemours to pay for filtration, and other entities like that. And the Water Safety Act would actually provide limits on PFAS, which our Environmental Management Commission is continuing to stall on. So I will end there, and thanks very much for your time.
Thank you so much, Dana, and thank you for sharing about your brother's stories. I think it's really important that we speak out about what firefighters are going through. Right now, I have several friends here in the Norfolk and Virginia Beach area who are getting tested for cancer. And with that, Dana kind of mentioned some of the stuff that's going on with the fish advisories, and this can be, is going to start getting applied to saltwater as well as we see PFAS end up in the ocean. So with that, I'm going to turn it over to Dr. Aaron Ramos, who is a marine ecologist, an environmental scientist with over 15 years of experience in coastal habitat conservation and community ecology in the southeastern United States. He is originally from Beaufort, North Carolina, and he served in 2024 to 2025 as a Sea Grant NOS Marine Policy Fellow with the NOAA National Weather Services Ocean Prediction Center and Office of Observations National Buoy Center. His fellowship focused on strategic planning to enhance the integration and impact of NOAA's in situ ocean observing systems. Previously, he was a STEM policy fellow in the Secretary's office at North Carolina Department of Environmental Quality, where he led PFAS field research in the Cape Fear River and contributed to major funding efforts, including North Carolina's $421 million multi-state grant proposal for carbon sequestration and coastal resilience under the Priority Climate Action Plan. He earned his degrees from the University of North Carolina at Chapel Hill and then the University of North Carolina Wilmington, where his research examined how invasive seaweed supports biodiversity and ecosystem functions in the absence of native habit forming species. He has authored peer-reviewed publications in top journals, including Nature Communications, Proceedings of the National Academy of Sciences, and Ecology. He is very passionate about bridging science and policy and is committed to advancing sustainable solutions for coastal communities and marine ecosystems.
Thanks, Gigi. Hi, everyone. Thanks for having me today. Can everyone see my slides? I hope so. Yes. Okay. So yeah, we'll just jump into it. I do want to say two things right off the bat. It's been a couple years since I worked for DEQ, so I'm a little rusty. So bear with me throughout this. And also, I do not work for DEQ anymore, and I'm not official representative of DEQ. So just a broad overview. Again, I think Dana kind of got us into this pretty well, but just where we're talking about in North Carolina, DEQ has done a lot of sampling throughout the state. And I'll leave that as it is for now. So these are just some results from DEQ. What are we? I got a bar right there. Groundwater monitoring. This is from 2023, I believe. Again, the different we see kind of different communities of compounds depending on where you look at them throughout the Cape Fear River region. Obviously, up closer towards Fayetteville, we see higher concentrations of Gen X and other attachment C compounds. Then down by the coast in the groundwater, we actually see there's perhaps more PFMOA, PFMOA, depending on how you want to call that. Anyway, so it's spatially variable is one of the kind of takeaways. And this is just some overview data from DEQ. So in 2021, DEQ did sediment sampling in the Cape Fear River. And we see one of the kind of dominant compounds that we're picking up is actually PFAS. And there's a really interesting trend here. And that as you kind of get farther away from the point source in the Cape Fear River, we actually start to observe more or less higher concentrations of cumulative some PFAS. Again, this is surface water data sampled during 2022. As you might expect, this is kind of like the trend we were generally anticipating. As you're closer to the point source, right here near this bend in the Cape Fear River, we see higher concentrations and generally more PFAS present. And we kind of see this decreasing concentration as you go downstream from there, which is generally something we would expect. Again, this is just a comparison across the sediment and surface water environmental media. These compounds are partitioning differently, which is very interesting. As we kind of see what I would call like opposite trends here. Okay, so I'll get into kind of the meat of this. This is more of what I was involved with at DEQ, which is the fish and surface water collection project. Again, throughout this region, obviously it's been affected by the point source. And the goal for lots of people that live here, subsistence fishing is actually kind of a big thing. They like to catch fish out of the river and eat them. So the goal was to collect surface water and fish tissue samples to analyze them and kind of understand bioaccumulation throughout the region a bit better. Okay, so to do this, we actually broke the river into 20-kilometer long segments. And so we had a whole bunch of these, as you can see on the slide here. Site A, just to clarify, is actually above the Fayetteville Works plant. So it's kind of intended as a control. Obviously, water doesn't flow uphill, even though fish can swim upstream, obviously. And then we're ending down here in what is Site H, which is a bit north of Navassa, which is slightly north of Wilmington. So these are just an overview of fish species that were collected. We aim to get 5 individuals of each species in each of those river segments. That's kind of a basic sampling design. For some species, they're not present in all segments, or they're not very abundant. So we're not able to catch those and get those numbers. But again, these are the fish that are most commonly caught and consumed in the freshwater parts of the Cape Fear River. So we did all the sampling with electrofishing, which is very interesting. If you've never been out electrofishing, I recommend that. And we collected over 200 fish from June to August 2022. So again, we prepared fish tissue following like standardized EPA methods. I forget the exact methods we were using, but there's large documents on those you can refer to. And we sent all these fish tissues off to, I forget, it's in South Carolina, the company that analyzes PFAS, and they screen for a panel of 56 PFAS compounds. Okay, we'll continue from there. So again, this is just kind of, we're also sampling surface water at the same time as we were sampling fishes, and so this is the overview of the surface water data. As you can see, we have Site A is again near Fayetteville and slightly above the point source. We see slightly lower concentrations there. Site B and C have the highest some PFAS concentration, and we do kind of see overall a decreasing trend in total PFAS concentrations as you go downriver. I will say that legacy PFAS, PFOA, and PFAS were present at all sites, and I think I'm also going to leave this. These are just to highlight some of the attachment C compounds that are detected associated with the Fayetteville Works plant. Okay, we'll keep moving. So this is PFAS data just for largemouth bass. Again, we're seeing really high concentrations of PFAS across all sites, legacy PFAS, but we don't see the same community, as I would call it, of PFAS as we do in the surface water. Sorry, I've got my notes down here. And again, we were just averaging the results across all 5 individuals collected at each site. So again, PFAS compounds that are present in surface water do not necessarily reflect the bioaccumulation that we're seeing in the fishes, which is interesting. And to kind of highlight that, this is the only small chain attachment C compound that we actually detected at Site G in largemouth bass. So again, these are this is just comparing PFAS, the most abundant PFAS compounds in largemouth bass and bluegill sunfish. These are all river segments, all individuals from all river segments averaged. Like I said, we're seeing the highest PFAS concentrations, with other PFAS being at much lower concentrations in these fishes. And what's also interesting is that we're seeing kind of the same community of PFAS, or the same players present, specific compounds, more or less in the different fish tissues that we're picking up. So again, we did some statistical analysis. We're just looking at PFAS concentrations in different species here. So we used generalized linear model with a Gaussian distribution that included a site, species, length, and weight to see if we could predict PFAS concentrations. Only species was a significant predictor of PFAS concentration. Okay, site, length, and weight were not. And so we think this is likely linked to their diet and trophic position. So what they're eating, where they're living, or do you eat crustaceans in the sediment, or are you eating other fish and things like that, which is an interesting result in and of itself. So just general kind of conclusion, what can we learn from this data? So PFAS compounds are not all found in the same environmental compartments, like we saw with surface water and the sediment water, but also with fishes. We do see that some PFAS accumulate at greater rates than other PFAS in fish, specifically PFOS. And one of the other things we've kind of learned throughout this process is that doing extensive environmental sampling takes a lot of time and effort and expertise, and it's usually not all done at the same time. And so really developing like a comprehensive perspective of PFAS contamination throughout the environment is very difficult. Typically, if this is done, it's usually done on a smaller scale. And so we're working towards doing that. Obviously, in the Cape Fear region, that's kind of like the pilot, larger level study. I will say I'm not allowed to speak about this beyond this, but there is saltwater data forthcoming. This is what I was primarily involved with DQ, was actually getting various saltwater species out of the lower Cape Fear River so we could run the same analysis. If you're interested in that, there are published studies from South Carolina on fishes. So you can look at FAIR et al. 2019 in environmental research. And SCDES has actually published an ArcGIS data map on PFAS compounds in invertebrates, including oysters and blue crabs, if I recall correctly, that they sampled throughout South Carolina. And with that, I will we'll do questions later, obviously. Feel free to reach out, and thank you for your time.
Thank you so much, Aaron. And now we will move on to our last speaker, which is Vaughn Hagerty, who is the Director of Communications at Cape Fear Public Utility Authority, which is the primary provider of drinking water and wastewater services in Wilmington and New Hanover County. Prior to joining CFPUA in early 2019, Vaughn spent more than 3 decades as a journalist, primarily as a newspaper and magazine editor. In 2017, he broke the story about researchers' discovery of Gen X and other PFAS from Chemours chemical plant on the Cape Fear River in drinking water and downstream communities. I think we can all thank Vaughn for bringing us into this problem, and he definitely is a source of why some people in Wilmington are aware of the issue. So with that, I will turn it over to Vaughn. Dana, you have a question? Vaughn, can you, are you talking?
He's on mute right now.
Okay.
All right, can you hear me?
Yes, there we go.
Yes.
We can hear you.
Okay, so thanks for having me despite the better efforts of technology to keep me away. All right, can you guys see my screen?
Yes, sir.
Yep, we
Okay.
can.
Okay, so again, thanks for having me. So what I'd like to do today is just provide a short overview of how, so I work for Cape Fear Public Utility Authority now, and I want to provide an overview of how our water system has addressed PFAS contamination in the Cape Fear River, which is the main source of water we treat for more than 200,000 people here in Wilmington and New Hanover County. And just to kind of set the stage for those of you who aren't really familiar with us, so we were formed in 2007. It combined the water and wastewater services of Wilmington and New Hanover County. It's a separate local government entity. We produce about 7 billion gallons of drinking water, and about 80% of that water is sourced from the Cape Fear River and the remainder from groundwater wells. And in this presentation, I'm going to concentrate on surface water and its treatment at the Sweeney Water Treatment Plant.
Hey, Vaughn, you're sharing presenter view, just to let you know.
Am I?
Yes.
So, okay. All right. Well, I guess I will have to do this. I'll have to just wing it then. All right. Is that better?
Yes, that is.
Okay. So our raw water intakes are on the Cape Fear River, and they're at Kings Bluff in Bladen County, which is about 25 miles from the Sweeney Water Treatment Plant. And as been mentioned in previous presentations, upriver from those intakes is the Fayetteville Works, and that's where Chemours and before it DuPont have had fluorochemical manufacturing operations for more than 4 decades. Now, by 2016, Chemours was well on its way from transitioning away from PFOA, which is a legacy PFAS, toward a substitute known commercially as GenX. And just like GenX, or just like PFOA, it was making GenX at the Fayetteville Works. And around the same time, some researchers from North Carolina universities and the EPA had begun testing water from the Cape Fear River for the presence of newer PFAS like GenX, which eventually was detected in raw, untreated water from CPUA's intakes and in finished water from the Sweeney Water Treatment Plant. So this is the article that was mentioned in my bio. So this was published in June 8th, 2017, and I was obviously not working for CPUA at the time. But for CPUA and our customers and the community who woke up to this headline, it was, it started a 5-year journey toward from a lack of confidence in drinking water to effective treatment for PFAS. So 5 years may sound like a long time, but in terms of major construction projects, it is really incredibly quick. So in that 5 years since 2017, CPUA went from the revelation about the discovery of GenX in our drinking water to the kickoff of construction in November 2019 and the startup of effective PFAS removal in October 2022. And you remember that headline that was on the previous slide that said toxin taints CPUA water. To right here, on the right here, you see a screenshot from when we started up the filters in October 2022. So a very different headline and a very different story. So this slide is a schematic of the filters that were built. So these 8 contactors are these box-like structures you see in beige in the figure to the right. So altogether, they hold 3 million pounds of granular activated carbon, or GAC. Now, GAC's effectiveness in removing PFAS is tied to its surface area. And one of our engineers calculated that if you were to somehow able to flatten out all the surface area in these 8 filters, they would be able to cover the state of North Carolina 3 times over. So by now we've had a few years experience operating this facility. And one point I want to make with this slide is that GAC has a useful life, or a saturation point. And after that, you have to either replace it or regenerate it. We regenerate our GAC, and to do that, our vendor removes the GAC media from one of the filters, and they transport it by truck up to their regeneration facility, which is located in New York. There, it's subjected to very high heat, and that high heat destroys the PFAS that's been absorbed. But the good thing, though, is that about 85% of the GAC remains after that. And that GAC is able to start absorbing PFAS once again as if it were brand new. So the cost to operate these is the largest part of the $5 million we spend each year just to operate these filters. So when we began operating our filters in 2022, when we built them, started building them, there were no regulations for drinking water, no PFAS regulations. But of course, that changed last year when EPA adopted national primary drinking water regulations for this small group of PFAS you see here. So these graphs show how we've been doing in terms of treating the PFAS in EPA's MCLs. And as you can see, it's either non-detect or very near non-detect very consistently for those. So in 2017, we were concerned with Gen X and other PFAS, some of the legacy PFAS, but we were testing for about six kinds of PFAS at the time, but that's grown significantly to where today we're testing for 65 types of PFAS, many of which are found only at the Chemours site. Now, one important feature of our design was that we wanted to make sure that it had flexibility. And so as I mentioned, we're currently using granular activated carbon, but it's also designed to be able to use things like ion exchange, which we could use to target other PFAS specifically. And this is important because we're continuing to see new types of PFAS contamination coming from the Chemours facility. And one class in particular that we're taking a close look at are called ultra short chain PFAS. Now, these are PFAS with a carbon chain or a chain of 3 or fewer carbon atoms. One of those, called PFPRA, actually broke through the filters fairly quickly. And one of the things we did, we increased the GAC regeneration to do it more frequently. But this also suggests that we may need to supplement GAC with other materials at some point. So in response to this challenge, we asked DEQ to help us understand and deal with Chemours-specific ultra-short chain PFAS. And we're also partnering with the NC Collaboratory to evaluate new novel sorbents to treat ultra-short chain PFAS. And that pilot testing, as you can see in the picture right here, began in 2024 and it's continuing. So addressing Chemours PFAS can be really expensive. In fact, by the first quarter of this year, we've already spent $80 million, and that's continuing. But not a penny of that has come from Chemours or DuPont. Instead, our customers are paying for it. So it's approximately accounts for about a $5 on the average customer's monthly bill. And so since these companies haven't stepped up to take responsibility, we filed a lawsuit in federal district court. Now, of course, these things can take a long time to play out, and we're still waiting to see a date set for this trial. And that is all I have for today. If you're interested in learning more about this, I'd encourage you to visit cfpua.org/clearlybetter. Thanks.
Thank you, Vaughn.
Yep.
Okay, and now we will start with some questions, just mindful of time. If you need to exit out of the seminar but have a question, please feel free to email us. I will include my email here and I can get it out to who it's appropriate. But if you please have a question, please virtually raise your hand. Or if you're shy, please feel free to put it in the chat and I will read it. Yes, Steve.
Yeah, barring others jumping in, I guess this is obviously great information and kudos to our speakers for their role in fleshing out this issue. Given the scope of the listeners we have, what, based on your lessons learned, what tips might you suggest to folks in other states, other communities, for, you know, taking steps to identify the kind of PFAS levels where, you know, the hot spots and whatnot that need to be really we need to be most concerned about, and then maybe moving towards taking action to address and mitigate for some of that?
I think that's an Aaron question. Happy to take it from my perspective. I think, I don't know. I don't think there's advice on how to find the hot spots at this point, because PFAS is everywhere. I think that's would be the advice that I would have for any community that has yet to find PFAS, is to go find it, because it's there. And then what, you know, our researchers are doing, which, you know, is amazing. North Carolina has a bunch of PFAS researchers are, you know, tracking. They found this pollution, and then they try to figure out where the source is. And I think that's key. But it also just needs to be reminded of everybody. And I just read an article yesterday in the New York Times about South Carolina, you know, a region in South Carolina that's just been highly contaminated, just acres and acres of land that had been applied with sewage sludge. And so we have to remember the fact that PFAS is used for that. So just laying over our farmlands, it's in our landfills, it's in our drinking water, it's in our consumer products. And so I think here in North Carolina, we have a lot more information about our PFAS contamination, primarily because of the North Carolina Collaboratory, which was funded by the budget in 2018, to provide funding for research. But those states that have yet to find it, I think, are just behind the curve on finding it, and they will once they look, which is the sad state from my perspective.
Vaughn, I see you have a question.
Well, no, I was just
Or
going to
comment.
yeah, I was just going to add to what Dana said, and that's that there actually is some data, right? So the unregulated contaminant monitoring rule, both the third one, which was, I believe that data came out in 2016, and then the latest one also, they both tested for PFAS. Now that's PFAS in your drinking water, but of course, you know, that's, if it's in your drinking water, you probably worry about it. So that data is out there for most or many of the larger or even medium-sized water systems. So I would encourage people, if you're interested, that data is available for download. There may be, I think the Environmental Working Group also may have made it searchable on their website too. And that's another source of information about where the PFAS hotspots are, would be the Environmental Working Group. So that those are places where, you know, individuals might go look.
Yeah, the EWG's website of testing your tap water, they've just updated actually, and they have very good explanations of why someone may want to buy a reverse osmosis water drinking system or a at-home granulated a GAC, granulated activated carbon filter, like you've mentioned, Vaughn, that CFPUA is using. And so we did have a question from Mara Rose, who was asking about northern New Hanover County near Murray Road. That is one thing that has been brought to me through my research, is that there are others that are not on well and not on CFPUA that are also concerned about their drinking waters. And there are some smaller utilities that also are most likely contaminated, as we know, because most of the area is, and those consumers are concerned and not quite sure who to go with for questions. And I'll turn that over to Dana.
Yeah, Gigi, I'm glad you mentioned that. So this is something we've been working on for a few years now. There's something that will be coming out from Cape Fear River Watch in hopefully the coming weeks, once this rep responds to me for the final time. But I've been working with DEQ and the primary small utilities down here, which includes Aqua and Sea and Carolina Water Services. And both of these entities are not doing anything near what CFPUA is doing. They're not even identifying the PFAS in their water to the degree that people know what it is, and they're not communicating to their ratepayers what's in their water, and it is disgusting. For 8 years now, these folks, I just sampled someone from Aqua and Sea 3 weeks ago. Our tiny nonprofit with a staff of 5 and a very limited budget should not have to be sampling someone from Aqua and Sea, which is a huge private water supplier in this state, to provide her what her levels are. And she had more than 60 parts per trillion of PFAS in her well. And I mean, in her drinking water supply. And that's a shared well, so it falls through the cracks of the consent order. It's not a private well, it's a community serviced by that private utility. And I've been fighting with that private utility for years now to get them to provide information to their ratepayers, as well as Carolina Water Services. So that is an issue. It's huge. And you know, their response is, we're working on our filtration. You're working on your filtration because the law just forced you to. And it's going to be years before that happens. In the meantime, those folks need to know that they're drinking PFAS.
And I just want to mention something. I have not published my work, but if you are feeling like you have anxiety around the drinking water, you are concerned, or you feel like the information that you have been provided by certain stakeholders in this is not forthcoming, and it sometimes feels like a lie, i.e. like how Chemours, that feeling is valid across the community. That there has been, you know, communication to make you feel like you are stupid, that you cannot understand this information because it is too technical. And if you need a prime example of that, you can see Chemours' Good Neighbors campaign. Jen,
if I could just add one thing, so if you're on a private well, I would encourage you, if you're concerned, to reach out to Chemours and get them to test your private well. There have been a number of people who have done that as under the consent order here, but probably not enough, right? And the more people that do it, the more the extent of Chemours and DuPont's contamination of our drinking water, right, will be known.
Hi, Jenny.
Hi, thanks. Thanks to all the speakers. Guys did a great job covering it, and thanks for everyone working to address this issue. So I just wanted to actually reiterate what Dana Sargent had said, and she put a link into information in the chat too about writing your legislators, because this is something that they pay attention to. We have been this squeaky wheel, and that's kind of how we got to where we are with the response that we have. I mean, we have a GAC, we have a consent order. Sure, it doesn't go far enough, but it's also important that we engage our legislators on this, because those 3 bills that are on, the House floor right now or in the Senate actually there's some really good stuff in there, and they need to hear from us to make sure that we know that they know that we want this. Casework's a real thing. So if you're feeling, like you want to take action, that's a very good place to start.
Just to be mindful on time, it is 12:06. Does anybody have any final questions they would like, or would they like anybody else for their email to be shared? Please let us know.
Yeah, otherwise, thanks very much, everyone, for joining. We have already seen a lot of people drop off, but appreciate our speakers staying on a bit longer to address some questions here. Great questions from the group. Great work you're doing, again, especially, considering the backdrop of Earth Week here. The work continues more than ever to help maintain a healthy environment. And so again, yeah, your efforts are appreciated. Thanks for taking the time to help educate us all today, and very much appreciated everyone who joined for some of the questions and tuning in and taking this knowledge and applying it for your own community.
Thanks
Thanks,
everybody.
Stephen.
All right. Have a good rest of your day, and be well.
Thank you.
Thank you, guys.